Good morning students. Today I am going to discuss about the next portion of the chapter, heat. Here I will mainly discuss about another mode of heat transfer, that is radiation. Now the question is, what is radiation? Radiation is the process by which the transfer of heat takes place without any need for a material medium. Students, I already told you about the methods of heat transfer like conduction, convection. In both the processes, medium particles are involved. Here you can see in the process of conduction, heat is conducted from the source through the metal rod to a person's hand. Here, atoms of metals are acting as the medium particles. In case of convection process, you can also observe, students, that air particles are involved. Air particles are acting as medium particles, which helps in the process of heat transfer, that is convection. But in case of radiation, no medium particles are required. If there is no medium, if it is vacuum, then also heat can be easily transferred from the source of heat to our hand by the method of heat transfer known as radiation. Have you ever thought, students, how does the heat from the sun reach the earth? Is it through conduction or convection? It is through radiation, because most of the space between the sun and the earth is a vacuum. This means that there is no material medium between them, so that only method of heat transfer is known as radiation, through which heat from the sun can easily reach our earth's surface. In this method of heat transfer, heat travels in the form of electromagnetic waves. These electromagnetic waves are particularly known as infrared waves. In this process of heat transfer, heat is traveled with the speed of light, that is 3 into 10 to the power 8 meter per second. The value of the speed of light is very high. That's why radiation is the fastest method of heat transfer. The energy transferred in the radiation process is called radiant energy. All hot objects emit radiant energy, which is then absorbed by other objects around it. Students, you might have observed, if you sit near a fire, you feel warm. The heat from the flame of the fire does not reach our body by the process of conduction. Why? Because air is present between the source of heat and our body. And as air is a poor conductor of heat, through conduction process, heat cannot reach our body. The transfer of heat also does not happen by the process of convection, as convection always takes place in the upward direction. So, radiation is the only process here. Now students, I will discuss about absorption of radiant energy. The amount of radiant energy absorbed by a body depends on the nature and the color of the surface of the body. Now students, let's do the activity to study the effect of color on heat absorption of a body. Let us take two identical tin cans. One is coated with black color, another one is made up of any shiny material or is coated with white color. Now fill the cans with equal amounts of water and install a thermometer in each can. Now if we place the cans in bright sunlight, after half an hour we will observe the temperature reading on each thermometer. Now students, what will you observe? You will observe that the temperature of water in the black can is higher than in the white can or the can which is made up of any shiny material. So, what have you understood from the activity? The can which was painted black absorbs more heat, and that heat is transferred to the water. That's why water is getting heated, so the temperature of the water rises. So what can you conclude? We can conclude that a dark or a black body absorbs more heat than a light colored body, or the body which is made up of any shiny or polished material. Now students, I will tell you about emission of radiant energy. All hot bodies emit radiant energy. The heat released or emitted by a body also depends on the color of the body. As I told you students that black colored objects are known as good absorbers of heat, as well as good absorbers of radiant energy is also a good emitter. It means the dark or black bodies are generally good emitters of heat. Let us do another activity to observe that a dark colored body is a better emitter of heat than a light colored body. Let's take two identical tin cans. One is coated with white color, another one is coated with black color. And both the cans are filled with boiling water. Now, allow the water in the two cans to cool by leaving the setup in a well-ventilated room away from sunlight. We can note the temperature reading on each thermometer repeatedly after time intervals of 5 minutes. Now, you can easily observe the temperature of water falls in the two cans, and you will observe the temperature of the water in black can falls more quickly. So what can you conclude students? A dark or black body emits more heat than a light colored body. Okay students, so learn the taught portion of the chapter properly from your textbook. Thank you.